Good afternoon, everyone.
Good afternoon, sir.
Okay, let us start. So we have been learning data, its source and compilation, and we shall continue the same. Now I shall share my screen. Okay, so here we have data, its source and compilation. The third part. Okay, so here processing of data, and see processing of data requires their tabulation, classification in selected classes. Okay, so last time we learned that say we cannot present the raw data in our report. Okay, say for example we have collected data from 1000 households, and all the data we cannot present, okay, in our report. So we need the tabulation and a classification of those raw data, okay, after selecting classes. And the first step is to group the raw data in order to reduce its volume and make it easy to understand. So one advantage of grouping of data, that is classification of data, is that it reduces the volume of the data, and it also makes easy to understand. So when we present the raw data of say about sex ratio, about literacy, okay, then say we may not be able to understand it easily. But after grouping the data, after classification of the data, so we can easily understand, okay, understand the data. So after reading the table, after reading the this classified data, we will be easily understand. Okay. Next we have this grouping of data. Okay. See, grouping of data, raw data requires determining of a number of classes in which the data are grouped, to be grouped in what will be the class interval. Okay, see, grouping of raw data requires determining the number of classes in which the raw data are to be grouped and what will be the class interval. Okay, so how many groups will be there and what will be the class? Okay, that is to be done in the case of grouping of data. Then the selection of the class interval and the number of classes depends on the range of raw data. Okay, just see here. In this case, say we have this the lowest value here. The lowest value, okay, just see here. Here in a range of in a series of data, we have the smallest value 2 and the largest value 96. Okay, and we can conveniently choose to group the data in 10 classes with an interval of 10 units in each group, that is say 0 to 10, 10 to 20, and so on. Okay, see here. Here, so we have to find out the range. Okay. Actually, see, range. Okay, I will open this MS Paint. So here, I think all of you may be knowing to how to find out the range. So we have known that what was the highest value. Highest value here is 96. So highest value minus the lowest value 2 is equal to 94. Okay, is equal to 94. And how many class you want, you have to decide. Okay, say for example we want a class of the number of classes, say we want 10 classes, so we have to divide it by 10. And if you divide 94 by 10, I think you'll get 9.4, I think. Okay, just let us check it. 94 divided by number of classes we want, so 9.4. That means we can take round number of 10. Round number of 10. Okay, and so we have, so we want this 10 number of classes, and the class interval will be 10 as per our calculation. So we can make the classes as follows: 0 to 10, okay, then 10 to 20, then 20 to 30, and so on. So that is the point mentioned here. Okay, so here the interval, the class interval we have chosen is 10, and accordingly so we have make the classes of 0 to 10, 10 to 20, and so on. So this is what I call grouping of data. Are you clear, boys and girls?
Yes, sir.
Okay, so here, so next we have process of classification. Okay, once the number of groups and the class interval of each group are determined, the raw data are classified by a method popularly known as pour and the cross method or tally marks. See, so we have in this case, so we have chosen the classes. Okay, and so once the classes are met, then what to do? Then we have to count the raw data, okay, falling in each group, and in that case we have to use this using of tally marks. Okay, that is for and cross method, that is 1, 2, 3, 4, 5. Okay, or sometimes it is also done like 1, 2, 3, 4, 5. Okay, then if you want 6, then we have to add one more line. So in this way we have to use pour and the cross method Say for example, under the class 1 to 10, okay, under the class 1 to 10, if we have the number of individuals here is 2, then 1, 2. And in case of 20 to 30, if we have 5, then 1, 2, 3, 4, 5. I think all of you may be knowing. So one tally mark is assigned to each individual in the group in which it is falling. So for example, the first numerical in the raw data is 47, and since it falls in the group of 40 to 50, one tally mark is recorded. So for example, 47, we have a numerical value of 47. So since 47 is coming under the class 40 to 50, then we have to record this one tally mark. Okay, in the class this is 40 to 50, we have to record one tally mark as follows. Okay, then about the frequency distribution, okay, the number of individuals is known as frequency, and the column represents the frequency distribution. It illustrates how the different values of variable are distributed in different classes. So the frequency distribution illustrates how different values of variable are distributed in different classes. For example, 0 to 10, how many frequencies are there, how many individuals are there. Then between 10 to 20, how many individuals are there. Okay, that is what I call frequency distribution. And the frequencies are classified as simple and cumulative. That means we have two types of frequency distribution. The first one is simple frequency distribution or simple frequencies. The second one is cumulative frequencies. Okay, so what do you mean by simple frequencies? So simple frequencies is expressed by f. So it is represented by f and represent the number of individuals falling in each group. And the sum of all the frequencies assigned to all the classes is expressed by symbol n, or it is equal to summation f. That means here, so we have got some values here. Okay, so let us say this is 3, this is 3, and so here this is the tally. Okay, this is the class. Then here we have tally marks. Then here we have frequency. Okay, frequency. Let us say here between 0 to 10 we have 2. Then 10 to 20 we have 3. Then 20 to 30 we have 5. So after doing this, after finding out the frequencies, what to do at the end, we need to find out the total values here. Okay, and that is represented by n or this summation f. Okay, n or what? N or summation f's here. So that is about simple frequencies, and about the cumulative frequencies, it is expressed by CF and can be obtained by adding successive simple frequencies in each group with the previous sum. For example, the first simple frequency is 4, next frequency is 5, and is added to 4, which gives a total of 9 as the next cumulative frequency. Very easy. We just see here. Next, what is the next step? Here, cumulative. Okay, this is cumulative frequency. So in this case, we have to add one after the other. Very simple. Okay, first we have 2, then after that what to do, this 2 plus 3 is 5, then 5 plus 5 is 10, I think. Let's see here. Here we have the first one, we have 2 here, then 2 plus 3 is 5, then 5 plus 5 is 10. So this is what we call cumulative frequency. Okay, so these are the two types of frequencies. One is the simple frequency, it is represented by f, and the total of f's is symbolized as n or summation f. And another type of frequency is a cumulative frequency, and it is expressed by cf. Okay, are you clear? Boys and girls, are you clear?
Yes, sir. Yes, sir.
Okay, then see, each simple frequency is associated with a group or class, as we discussed earlier, and we have two types of classes: exclusive, okay, and inclusive methods or classes. So what are the exclusive methods of classification, and what are the inclusive methods of classification? Let us see. So this is about exclusive method. So in this method, the upper limit of one group is the same with the lower limit of the next group. Okay, so in the exclusive method, the upper limit of one group is the same as the lower limit of the next group. For example, upper limit of one group, that is 20 to 30, is 30. The upper limit of the class 20 to 30 is 30, and which is the lower limit of the next group? Here, 30 to 40, and making 30 to appear in both groups. Okay, in this case also see here, say upper limit. So this is the upper limit of the first class. So the upper limit of the first class forms the lower limit of the second group. Okay, in this way, thus making this 10 two times here. That is the point mentioned. Okay, and but any observation having the value of 30 is included in the group where it is at its lower limit, and is excluded from the group where it is the upper limit, that is in 20 to 30 groups. That means, see, in this case, say for example, we have a value of 20, for example. We have a value of 20. So in which class we have to include? Just tell me, boys and girls. We have a raw data of 20. So in which class? Here or here? In which class 20 is to be included? Yes? Yes, anybody? See, as mentioned here, okay, any observation having the value of 30, this is example, okay, 30 is included in the group where it is at its lower limit, and is excluded from the group where it is the upper limit, as in 20 to 30 group. That means here this value 20 will be counted here in the class where okay, it is in the lower group. So here in the class of 10 to 20, 20 will not be counted. 20 is excluded, and hence the name is given. Okay, exclusive series or exclusive classes. So here in the case of exclusive class interval series, okay, exclusive method, 20 is to be counted here in this group where it forms the lower limit. Okay, where it forms the lower limit, it is to be included, and to be excluded in the class where it forms the upper limit. Okay, So that is why this method is known as exclusive method, and that is a group is excluded. A group is excluded in its upper limit. Hence, the group 20 to 30 is interpreted as 20 and under 30. 20 to 30 class means 20 and under 30 means less than 30. Okay, 20 and under 30. So this is exclusive method. Next we have inclusive method. Here in this method, the value is equal to the upper limit of a group is included in the same group, and it is known as inclusive method. So we have example. Okay, we have examples. For example, 40 to 49, then 50 to 59. And normally the upper limit of the group differs by 1. See, differs by 1. See, 40 to 49, then 50 to 59. So it differs by 1. 50 minus 49 is 1. So normally the upper limit of the group differs by 1. With the lower limit of the next group, the upper limit of the one group differs by 1 from the from the this group. Let me repeat. The upper limit of this group differs by 1 from the lower limit of this group. So it is important to note that each group spreads over 10 units in this method. For example, between group 50 to 59 include 10 values, that is 50, 51, 52, 53, 54, 55, 56, 57, 58, 15. That means see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That means between 50 to 59 we have 10 values. So in this case, in our case, so it is to be made like this: 0 to 9, okay, 10 to what? 10 to 19, then 20 to 29. So this is what I call inclusive series. So in this case, a value of 9 will be counted here. Say for example, here we have a value of 9. So 9 is to be counted. This value 9 is to be counted here. It is included here. Likewise, another value, for example, another value 19. 19 will be where? This value 19 will be here in this group, and value 20, for example, another value we have 20. Okay, this 20 will be here in this group. This is what I call inclusive method. Are you clear? And when we say a class of 20 to 29 here, so it contains 10 values. Okay, so when we say a class of 20 to 29, it means that we have a value of say we have 10 values. Say for example 20, 21, 23, 20, 21, 22, 23, 24, 25, 26, then 27, 28, 29. Okay, that means let us count. Okay, so see here 21, 2, 3, 4, 5, 6, 7, 8, 9, 10. That means between 20 to 29 we have 10 values. Okay, in the case of this inclusive method. Are you clear? It is also mentioned here in this method both the upper and the lower limit are included. to find the frequency distribution. So in this case, both the upper limit and the lower limit are counted. So this is about inclusive method. Okay. So are you clear, boys and girls?
Yes, sir.
So next we have some examples. Okay, we have some activities here about demographic ratios. Last time we talked about demographic ratios. Okay, about how to calculate the demographic ratios. Now let us practice it. So we have equation here. Calculate the crude death rate of two towns A and B. Okay, and their age composition and mortality patterns are given here in this table. So these are the age groups. Okay, so these are the different age groups, and so this is the total value. So this is the population of the mid-year, okay, of the age group, of the particular age group. For example, this is the population of the age group 20 to 50 years. So the population of the age group 20 to 50 years is 4,000, and the number of death is 120. Okay, so for the less than 5 years 180, and so on. So this is the total value, and this is for the town V. And for the town V also, just say these are the population for the different age groups. So for example, for the age group 5 to 20 years, we have population of 2,200, okay, persons, and the number of death is 55. So this is the question, and here we have the calculation. Crude death rate for a locality is found by dividing the total number of deaths in that area during the year in question by the number of people living in that locality at the midpoint of that year. Actually, we have also learned about the formula in the theory classes. Okay, in the population classes we have learned. See here, this is the formula. CDR is equal to D by P multiplied by 1000. So if you want to express it in terms of thousand, so we have to multiply it by 1000, and if we want in percent, okay, in 100, then we have to multiply it by 100. But generally we mainly express in terms of thousand or per milli. Okay, so CDR stands for crude death rate, and D refers to number of deaths, and P estimated mid-year population of that year. So here we have the calculation. So these are the result. Okay, these are the result. So this is the death rate. How to calculate? Just see crude death rate of town A, for example. Here the total one. So this is the population of the mid-year for town A, and this is the number of deaths. Okay, so applying the formula, simply we are using this symbol. Okay, N1 for the number of deaths for town A, N2 number of deaths for the town B. So say when we divide the number of deaths by the mid-year population and multiply it by 1000, so we have got 45.7. That is, this is the number of deaths, 640. 640 is here, and here this is the total population, mid-year population. Okay, it is here, and after this we have got 45.7. So this is the death rate. Similarly, for the town B also, applying the same formula. So N2 refers to the number of deaths of town B, and the P2 the number of population for the mid-year population for the town B. So here we are dividing this 336 by the mid-year population 9000, and multiplying it by 1000, so we have got 37.3. Likewise, see here Okay, see for the this particular group also, we have to find out. It is very easy, okay. We have to do like this. So here, what is the value here? That is 1 IT, 1 IT, okay. 1 IT divided by what? So the dat rate here is, the number of dat for the age group 0 to 5 is 1 IT, and the mid-year population is 3000. So mid-year population is 3000. Okay, so multiplying it by 1000, so we have to express it in terms of thousand. So let us see. Okay, just let us find out. See, 1 IT divided by 3000. Okay, then multiplying it by 1060. That means here the death rate is 60. Okay, alternately you can multiply 180 by 1000 and divided by 30, and you will get this 60. Okay, as the death rate here for the age group less than 5 years. Likewise for the town view also we have 50 and so on. Okay, then like that we can also find out the crude birth rate. See, it is found by dividing the total number of birds in the locality during the year in question to be divided by the total population of the locality at the midpoint of the year. And the formula is given here as given in your textbook. CBR is equal to BI divided by P, multiplying it by 1000. So CBR stands for crude birth rate, BI live births during the year, and P is equal to mid-year population of the area. So you may try, okay, so you may download any data from the internet, and you may try applying this formula. Okay, and another activity here we have a calculation of sex ratio. So calculate sex ratio of the following selected states to India. Their population number of males, females are given. Okay, as follows. So some states we have selected: Himachal Pradesh, Punjab, Uttarakhand, Haryana, Rajasthan, Bihar. Population of each states are given. Number of males given. Number of females given. And we have known the formula also. Okay. The ratio between the number of women and the men in the population is called sex ratio. And in the case of India, sex ratio is calculated using this formula. So this formula is mainly used in India. Sex ratio is equal to female population to be divided by male population, multiplying it by 1000. So this is for India. However, in some these European countries, in some Western countries, okay, say sex ratio, sometimes they are using this formula. Can you tell me the formula that is used in the book 1? So in this case, so number of males are here, the number of females are here, and it is to be divided, multiplied, okay, by 100. So in this case, sex ratio is expressed in terms of number of males, per 100 females. Okay, it is expressed in terms of number of males per 100 females. So how many males are there per 100 females? So this is also used in Western countries. However, for India, we have this formula. Okay, it is expressed as number of females per 1000 females. How many females are there per 1000 males? So this is for India, and accordingly we have got the sex ratio here applying the formula. Say for example Himachal Pradesh, very simple. Okay, so Himachal Pradesh, we have number of females here. Okay, the number of females you have to put here, then the number of males you have to put here. Okay, and to be multiplied it by 1000, and after that you have got 972. Okay, and similarly you can find out for Punjab, then Uttarakhand, Haryana, Rajasthan, and Bihar. Okay, and you may try using this formula also. Okay, so you can try using this formula. Okay, any question, boys and girls?
No, sir.
Okay, then let us stop here for today. Thank you very much for joining my class. Thank you all.